We are going to be doing quadratic function transformations, and today we're going to be looking at it in vertex form. And so each of the pieces, the A, the H, and the K, are going to tell us something. And so we are going to go through each of the pieces one at a time. So first off, if your A, the absolute value of it, is greater than 1, the graph will appear visually narrower, but the technical term for that is called a vertical stretch. If your A, the absolute value of it again, is between 0 and 1, the graph gets wider. This is called a vertical compression. If you compress a spring, it gets fatter. If you stretch it out, it gets narrower. This is the same idea with this. Now, the third thing that could be is if your A is negative, the graph is reflected over the x-axis, and that's called, or it reflects vertically. Now let's look at what's happening with the H and the K. H is a horizontal shift. K is a vertical shift. And your vertex will appear at H, K. So that's the order pair for your vertex. So let's look at this first one. So if we look in front, there's no number here, so that means it's a 1. So that means it's not having a stretch or a compression, and it's not flipped, it's positive, so it's not flipped vertically. So let's now look at your vertex. Your vertex is an ordered pair, and it's H, K. It's always going to do opposite of the inside and the same sign for the outside. So 1, -3. And so we'll come over and plot that point at 1, -3. And then the pattern it's going to follow, if it does not have a stretch or compression, it's going to follow the same pattern as if we did the parent function. And so I'm going to go ahead and sketch in black the parent function of the parabola. The parabola follows the pattern as up 1 over 1. And then from that point, up 3 over 1. And the next time it would actually go up 5 over 1. It's going to mirror the same thing on the left that it does the right. So once you have your right in place, your left will follow. So now let's look at the transformation, the way that's going to work. So we started off at the 1, -3, and we go up 1 over 1, up 1 over 3. And we don't have enough room to do the next one up, so we'll stop there. 1, and then 3. So remember, this is a 3 jump, this is a 1 jump. And then sketch it in. So if I was to, in words, describe what happened, I had a right 1 unit and down 3 units from the original parent function, which was graphed in black. And the original parent function is f of x equals x squared. Let's look at another one. So in this one, I've already got sketched in black the original parent function. We just have to find the vertex. So pause it and see if you can find the vertex. So our vertex is now at 2, -4. And there is no stretch or compression on this one, so we just went up 1 over 1, up 1 over 3, and then there is enough room for us to do the last jump, which is up 1 over 5. So it goes 1, 3, 5. And then we sketch that in. And so let's describe in words the transformation. This is a parent function. So we went right 2 and down 4. So on this one, the next one, we actually have an A. So that means that A, I need to look and see, is it greater than 1? It is. So that means that this is going to be a narrower graph. So this is has a vertical stretch of 2. And then we'll find our vertex. Pause it and see if you can find the vertex. So we do opposite inside, and there's nothing outside, but we have to understand that there's a 0 outside if nothing else is written. So I went right 2, and now because I have a stretch of the 2 out here, it's going to double all my moves. So if I originally went up 1, I'm going to go up 2 this time. If I originally went up 3, I'm going to go up 6. Well, 6 is going to be off my graph, so I'm going to go ahead and sketch what I have. The other transformations that if I do the verbal description is I went right 2 units. So it's had a vertical stretch of 2 and went right 2 units. This time, our A term is 1/2. So that means it's between 0 and 1. So this means it's a compression. So vertical compression. Of 1/2. Now, the next one we have to do is identify our vertex. Well, if I look inside, there's nothing else written, so that's 0 plus, or x plus 0. So my vertex is at 0, comma, -4, because it's the same outside. So 0, comma, -4 will be down here. So I go over 1, up 1/2. Because I'm going to take that step of 1 and multiply it times 1/2. I'm going to take the step of 3 and multiply it times 1/2. So that's going to be 3/2. which is going to put us up here at 4. The next one's going to be 5/2. And so forth. So my graph is going to be a little bit wider. And so my translations is I went down 4 units this time. So again, let's look at our A. It's negative, that means it's reflected over the x-axis. Another name for this is a vertical reflection. Now we'll find our vertex. So our vertex is HK, H coming from the inside, and we opposite inside, so -3, comma, the same sign outside. Well, there's nothing written, so that's understood to be a 0. So -3, comma 0. So if I go to -3, that's going to be back to the left 3. And then I am going to be reflected over the x-axis. That means instead of going up, I'm going to go down. So I'm going to go over 1, down 1. Over 1 from there, down 3. So it's still that same steps, but instead of going up, I'm going to be going down. And then just drawing my parabola. So in this next one, we have a -2 as our A. And so -2 falls between an absolute value of 0 and 1. So this means this is a stretch of 2. But it also has a reflected of across the x-axis. Now let's identify our vertex. So we need to do opposite inside. So the opposite of -1 is 1. The same sign outside. So we're going to be at 1, 1. So this means that I went right 1 and up 1. So I'm going to start at that 1, 1 spot. And since I have a reflection across the x-axis, that means I'm going down. And since I have a stretch, that means I'm doubling every transformation. So instead of going down 1, I'm going to go down 2. So I go right 1, down 2. Right 1, down 6. Well, 6 is off the page. So let's mirror the left. And then sketch my graph. So that's going to be the graph reflected across the x-axis and with a stretch. The next one, our A, is just a -1, so that means all I'm doing is reflecting. So reflecting across the x-axis, there is no stretch or compression, but our vertex, again, we do opposite inside, so opposite of +1 is -1, same outside 2. So I'm at -1, +2, and so that puts my vertex here. And I reflected over the x-axis, there was no stretch, so all it means is I'm going down instead of up. So go over 1, down 1. Over 1, down 3. And sketch in that graph. So there was a left 1 and up 2.